Hello, math enthusiast. Listen, we have a coordinate geometry question here, and how are we going to attack this question? Well, let's read this information above the rectangular coordinate plane here. It says the diagram below represents the graph of a straight line which passes through the points P and Q. So here we have the rectangular coordinate plane, which has the x and y axis. All right, the x axis and y axis. And we have the straight line PQ passing through both point P and Q. And the question says, first question, part A, state the coordinates of P and Q. So each point has two coordinates, a pair of coordinates, in other words. So point P, what are the coordinates of point P? In other words, where is point P located on the coordinate plane? If we look at point P here, we can see that it's located on the y-axis. And any point on the y-axis, the x-coordinate is 0. And if you look at it, this point here, go down to the x-axis, that is this horizontal line. If you go straight down to the x-axis, it'll hit the origin, which is a location of 0. Okay, 0, 0. So, in other words, the x location is 0 for this particular point P. And so I'm going to write it here like this. The x-coordinate is 0. And the y-coordinate, the location of the point on the y-axis, which is 3. So the y-coordinate is 3. Now let's go to point Q. Point Q has has one pair of coordinates, an x-coordinate and a y-coordinate. So let's look at point Q here. Since point Q is actually on the x-axis, the y-coordinate is 0. But the x-coordinate of the point on the x-axis here is -2. So point Q is at -2 on the x-axis. We're going to put -2. I remember we said that the y-coordinate will be 0. And so what do we notice? When a point is found on the y-axis, its x-coordinate is 0. When a point is found on the x-axis, its y-coordinate is 0. Now, part B says, determine the gradient of the line segment PQ. Several ways we could do this. We could use the option of rise over run, or we could use the coordinates and determine the gradient as well. Let's use the coordinates, P and Q. So we know the formula for the gradient. We use small m to represent the gradient. And we said rise over run, right? But we can also say y2 minus y1 over x2 minus x1. Now all this is saying, guys, is that we want the difference in the y coordinates of the points divided by the difference in the x coordinates of both points. But we must do this in a particular order. So let's label these. So I'm going to call, well, the first coordinate is the x and the second coordinate is the y coordinate for both points. All right. So let's call this coordinate here x1. And let's call this coordinate here x2, because those are the x coordinates. Now, since we're going to look at point P as point 1, the y coordinate will be y1. And for the second point, the y coordinate will be y2. All right, so remember, pair coordinates will always have x first, then y. X first, then y. We'll label these as the first point. We'll label this one as the first point and this one as the second point, indicated by the 1s and the 2s. Okay, so now we're going to substitute into the formula for the gradient. y2 is 0, so we're going to have 0 here. So we're going to take the second y coordinate, 0, and subtract the first y coordinate, which is 3. Let's look at the x coordinates now. Second x coordinate, which is -2. I'm going to subtract the first x coordinate, which is 0. And so this will give us 0 minus 3 is actually -3. And -2 minus 0 is -2. If you ignore the 0, you'll see you have -3 here, right? Subtracting 0 is like just leaving -2. Okay. Now, negative into negative is positive, and 3 divided by 2 is 1.5, or we can say 3 over 2, which is another option, or we can write it as 1.5 as we said, which is same thing as 1.5. Either way, same answer. Now let's get part 2 of B. The equation of the line segment PQ. The equation is y equal mx plus c. That's a form we're looking at, right? And this is a general form. We want the specific form where we have m and we have c. Now we found the gradient already. The gradient, which is m, is actually 3 over 2 or 1.5. Well, let's leave it as 3 over 2. So we're going to replace the m with 3 halves. We'll put back the x. And the c here, the c is where the graph cuts the y-axis. So c, this value of c, is where this particular graph that we have here cuts the y-axis. And it cuts the y-axis at 3. It passes through the y-axis at y equals 3. And so c is actually positive 3. Okay, so c is known as the y-intercept. So the m is the gradient and c is the y-intercept. Now, if we didn't have the graph, the other way we'll do this, we'll put y equal 1.5 x plus c, right? We do not know what c is. And what we do, we take one of the points. Let's say we're given the point 0, 3. Well, we put the 3 where y is, since it's a y coordinate. Put the 1.5 here, or the 3 over 2. The x is what? 0. Let's put the 0 here. Put back the plus c. And then we will say we have 3 equals 1.5 times 0 is 0 plus c. And 0 plus c is still c. And so we have c equals 3. And so we just replace this c here with 3. So that's another way we could have done it. We just plug in the value of y and x from any one of the point on the graph. If we had used -2 and 0, we still have gotten c equals 3. Okay, because time is going, let's go down to the next part of the question. Remember, this is our solution, right? The equation that we're looking for. All right, let's go down to here. Part C, the point -8t lies on the line segment PQ. Okay, so basically, they're telling us this. There's actually a point that is on the straight line, right? Remember, the straight line is this, defined as this equation 3/2 x plus 3, right? And they're saying that there's a point that lies on this particular line with the equation, this equation. Well, this one here. What it's telling us, when x is -8, y is some value t. So what is the actual value of y? Well, if we look at this graph here, we probably could go out until we find x. Well, we have to go this direction to find -8. And when -8 is somewhere far out here, right? Well, 3 units from -5 to the left. We go down, and where it hits this graph, but this graph extends further down onwards forever. And so where that x value, that line x equal -8 hits this particular graph, then we go across to find the y value. But I mean, we don't have it here. We can actually use the equation to find that. Let's see how. All we got to do is to take the x value and substitute it. So we can put y equal 3 over 2. Replace x with -8, since that's what it is in this case for the point -8t plus 3. So this equation will help us to find either the x or the y given one and not the other. So we're going to have y equals 3. What is 3/2 of -8? Well, let's do it the other side here. 3 over 2 times 8. We know it's -8, so let's put it there. 22 goes once, and 2 goes into 8 4 times. Okay, we simplify numerator with denominator. And 3/4 is 12, and since we have a negative here, it's going to be -12. So that's going to be -12, but the plus 3. All right, so we could have actually done it here. We could have said 22 goes once, and 2 goes into 8 4 times. So 3 times -4, -12. And so we have y is equal to, the signs are different, so we're going to subtract. We're going to get 9 and keep the sign of the negative, since we have more negatives than positives. So when the signs are different, it's telling us we have to subtract the numbers, even though we have a plus 3 here, because we're really adding 3 to not 12 but -12. And -12 is actually on the left hand side of the origin, so you have to go 3 units to the right. So we're at -9. All right, 3 units closer to the origin. Anyways, back to this though. So we found the y coordinate. So it's actually -8. The actual point is -8, -9. Okay, so we found the y coordinate. This is the answer we're looking for. T is equal to, make sure we state it, T is equal to y, which is equal to -9. All right, let's go down now to the last question. It says here, the line segment AB is perpendicular to PQ. So we know AB, the line segment AB, has equation what? Y equals 3/2 x plus 3, right? This line, well, not the line segment AB, my bad. Let's correct that. All right, so we know the line segment PQ has this equation, right? Not AB, okay? We just have to double check this. It's actually PQ. This is line segment PQ. And the equation we found for it was what again? We figure out that it's actually y equals 3/2 x plus 3, right? Because it actually hit the y-axis at 3, so this would be 3 here. But so that's the line segment PQ. That's the equation for it. It's defined by this. We have some line segment. We have some line segment AB now, and we're trying to figure out what is its equation. All right. So we know the general form is y equals mx plus what? C. And so we need to figure out what is the gradient of that particular line segment AB, and where does it cut the the y-axis? Right, where it cuts the y-axis, well, we're not sure yet, but let's figure it out. So we know that when there's something we know about perpendicular line, right? If two lines are perpendicular like this, let's say we have one line going like this direction and this line going this direction, so they actually hit each other at 90 degrees, right? 90 degrees. They pass each other 90 degrees. We say the two lines are perpendicular in that case, right? And there's something that the mathematicians have found out, that when two lines are perpendicular on the rectangular coordinate plane, there's something specific about their gradients. And what is that? Well, their gradients are the negative reciprocal of each other. So for instance, let's call the gradient of this one m1 and call the gradient of this one m2. Now what is the gradient, by the way? The gradient is just the steepness of the line, how the line is sloping. We also call it the slope of the line. All right? It's a number that measures how steep the line is. Okay, so back to this. So if let's say one gradient is a half, then the other gradient will be the reciprocal, which will be 2/1 in that case, or 2. And let's say this one is positive, it means that this one is negative. That's what I mean by negative reciprocal, the negative reciprocal. If one is 3/4, let's say -3/4, then the other one will be the reciprocal, which is 4/3, right? But since this one is negative, then this one will be positive. So their signs are different. That's one thing you need to know about two lines that are perpendicular. Their gradients have different signs, okay? And they are the reciprocal of each other in terms of the numerator and denominator. If it's 3/4, this is going to be 4/3. So that's a concept, okay? Now, that's not what we're looking at here, though. Let's go back to the original concept here. What's the gradient of line PQ? Let's call the gradient of line PQ M1, right? So M1, right, will be 3/2, okay? That's a gradient for line PQ. Okay, so the gradient for line AB, therefore, let's call it M2, right? Second gradient. In this case, it's going to be the negative reciprocal. So we're going to flip to get the reciprocal 2/3. Just spell that so you can actually get it, reciprocal. All right. And we say if one is positive, the other one is negative. But we know for sure that this one is positive, given the equation that we have here, what we worked out. So this one will be -2/3. That's all. Very easy, right? So we figure out the gradient of this perpendicular line. Its gradient will be the reciprocal of the other one that we figure out, and it will have the opposite sign. That's it. But let's carry on though, because what we want to find out is not the gradient only, but the equation of the line. So two things we need. Again, we need the gradient of that line AB, and we also need what? Where it cuts the y-axis. So let's find out that now. All right, so let's take this off. Okay, so back to this. I mean, if you're still watching this video, it means that you really benefited from it. You're benefiting from it, that is. So I think you should go ahead and subscribe, right? Hey, give me some more subscribers, man. All right, so let's carry on. All right, so we have what we have so far. We have the gradient of line AB, but we need the what? The y-intercept, that C value there. Okay, so all we got to do, guys, we need a point that passes through line AB. If we get a point that passes through it, we're good. So let's go back here. Let's see if there's a point that it passes through. Yes, it says the line segment AB, right, passes through 6, 2. We know it's perpendicular to PQ, yes, but we're focusing on the other part that says it's what? It said it actually passes through 6, 2. That means the point 6, 2 is on it. Okay, so just like this line PQ here passes through this point P is on it. It passes through it, it's on it. Okay, so we have the point 6, 2, right? With the point 6, 2. That is actually found on line AB. All right. So what we're gonna do? We're gonna write the equation that we have. Let's write this. So far, what do you know about line AB? Line AB. Let's write this instead. Line AB has gradient. Right? Has a gradient of -2/3. Right? It has an x coordinate of 6. Well, a point on it has an x coordinate of 6. And when the x coordinate is 6, the y coordinate, right, is 2. So we're going to use this concept. All right. This information. We're going to use this information now and substitute that into the equation y equals mx plus c. But remember, this one is for line AB that we're dealing with here, right? So let's substitute that into it. I mean, this is general form. Okay, so for the specific line AB now, we're going to put that information in. Y being 2, m being -2/3, and x being here being 6. That is, this is a gradient, m times 6 plus c. Now we're going to have 2 equals, let's simplify this. 3 goes into, let's put it at the side here so we can actually see what's happening here, right? 3 into 3 goes once, into 6 twice, and 2 2's give us 4, right? But remember, it's actually -2/3, so if with a negative here, this can be a -4. So this work out to be -4 plus c. And then now, what we're going to do now to find c, we want to isolate c, so we're going to actually add 4 to both sides. We're going to add 4 to this side to cancel it out. So we have c only on this side. We have to add 4 to this side as well. And so we have c equals 6. All right? So that means this particular perpendicular line cuts the y-axis at 6. So it's going to be what? It's going to be somewhere up here, right? It's going to be cutting it somewhere like this. All right? It's going to cut through and hit the y-axis at 6. But it's perpendicular, so it should be slanted like this, since this one goes this way. All right. So the equation of this perpendicular line AB then is going to be what? So the equation, all right, of line AB, all right, is going to be what? Y equal m, the gradient is -2/3, x, and the c value is 6. The gradient m and the y-intercept c, those are fixed. We call these are constants. But the variables y and x, we have so many. They're variables. They can take on any value. Hope that is very clear.